Hello, in this video we're going to look at an equation and an inequality. We've got a lot going on, so let's take a moment to read, and I'm reading at the top what is in the blue font. The ideal gas law does not take into account the size of the molecule of the gas. And so for this reason, many chemists prefer the van der Waals equation. The van der Waals equation uses T for temperature in kelvins, V for volume in liters, and P for pressure in atmospheres. The van der Waals equation for carbon dioxide is given here on this slide. And so the first bullet point says, what volume does this equation predict for 1 mole of carbon dioxide at 298 kelvins and 30 atm? So one first piece of this is to figure out, where do I put the numbers that they gave me? And so looking at this, the numbers that they gave me, the kelvins, that is a temperature, so that is an uppercase T, and that's going to go in the formula here at the T. And then the 30 atm, well, atm is the measure of atmospheres, and that is for P for pressure, so this is going into the formula for P. So this is going in right here, the 30. Now, one of the things that students have found incredibly confusing on this is this ATM at the end. This ATM is a label, so that is not part of our formula. So I'm going to rewrite this formula based on the numbers that they gave me. So I have 30 is equal to, put my first fraction bar, 0.082 times the 298, and that's over V minus 0.043. And then I have subtracted from that the fraction 3.592 over V squared. So it tells us here, what volumes does the equation predict for 1 mole of carbon dioxide at the 298 degrees Kelvin and the 30 atm. So it is asking me what volume, and so I'm actually supposed to solve this for V. And when I look at this formula, V is in the denominator and V is squared one place, so this is not something that's easy to solve by hand, and so I'm going to follow their direction and solve by the graphing method and also zero method. In the graphing method, we're going to make each side of this equation its own piece in our calculator. So this side, the 30, is my y1, and this entire side over here with both fractions is my y2. So I'm going to go to my graphing calculator and try to get this all typed in, and I encourage you to grab your graphing calculator and do the same. So going into y equals, clearing out my last problem. And so we said on the left, we had this 30, so our y1 is 30. And on the right, we had our whole big formula. So I'm going to attempt to type that on the top of the fraction, 0.082 times 298 divided by, make sure you're using parentheses around the denominator, so divided by, there's a v, so I'll put x minus 0.043 and end that parenthesis, and that's the end of that first fraction. And so then I'm going to subtract the second fraction, which was 3.592, divided by, I don't need parentheses here, but it wouldn't be wrong. I don't need parentheses because there's just one term, which is x squared. All right, so I think I have it typed, and I really don't know anything about this. So I'm going to have to look in my table to see if I can figure out what kind of numbers to use, how to draw my graph. So I'm going to go second window, start at 0, go up by 1. That seems reasonable as a good place to start. And second graph gives me a table. All right, so the y1 is always 30. The y2, which is where we have that big formula, it starts out as an error, so that's interesting. And then the numbers that I see here are significantly less than 30. So I'm hoping that between 0 and 1, it goes to higher numbers for y2, because otherwise it's never going to equal 30. So I'm going to go back to my table setup. And I'm going to try to break it down a little bit further. So I'm going to start at 0, and I'm going to go up by 0.1 so I can see what's happening from that error message at 0 up to the number 1. So again, look at our table. Oh, this is good stuff. All right, so at 0.1, the function does have a value, doesn't have an error anymore, and it's up at 69.5. And then I can see that it's going to equal 30 somewhere between 0.6 and 0.7 because that's where it's above 30 and then below 30. So there's going to be an intersection in there. So that is incredibly helpful because now I have an idea how to set up my graph. So I'm going to try to piece together this idea of how to set up my graph back at my PowerPoint here. So I have two axes going on. My input variable where I type the X is the volume. So this is the volume. And we saw that our answer was going to be a decimal somewhere between 0.6 and 0.7. So I'm going to go a little higher than that just to give myself plenty of room. So I picked 5, but like 2 or 3 would work there. You don't have to go the whole way to 5. And then my output of this function, my other axis, is the P, the pressure. And we saw at 0.1 it was 69.5, so about 70. So I'm going to put that up to 70, starting these both at 0. All right, so now that I have laid this out, I'm going back to my calculator. I'm going to hit the window button. So X, we said I was going to make it 0 to 5, although you wouldn't have had to go that high. And Y, we said we were going to go 0 to 70. And we'll hit graph. Okay. So what we see is the graph starts here, doesn't quite hit the axis, starts here in the red, comes crashing down, and then levels off. And we see this blue line at 30 go across. And so I'm going to figure out where they intersect because that would tell me where they're both 30. So second, trace, option 5 for intersect, enter for first curve, enter for second curve, enter for guess. So at 0.696, it is equal to 30. So I'm going to go back and draw this information on my graph. So the graph starts here just a tick off 0, comes crashing down and levels off. A line comes across at 30. And these two guys meet here at 0.696, comma 30 is that ordered pair. All right, so to answer the question, what volume? Well, the volume was the X value. So a volume of 0.696, how is volume measured? Going way up here at the top. V for volume in liters. So that many liters. So the volume would equal 0.696 liters when the pressure is 30. So that's the graphing method. Your homework system will often refer to this as crossing graphs because we graphed 2 lines and found where they crossed. So the other method is the zero method. And in the zero method, we have to have our equation equal to 0. So if I look up here at my equation, I'm going to switch pen colors so we know that we're doing a different method. In order to get this to be 0, I need to subtract it. So I'd have to put minus 30 onto my equation. So I'm going to go take care of that in my calculator. So in the zero method, I don't need this first 30, so I put clear. And then in my formula, I'm going to arrow out to the very end of it. And I'm going to subtract 30 because that made the equation equal to 0. And that's what I wanted. I wanted to use the zero method. This means I need to adjust my window. So in my window, the X can stay the same, 0 to 5, but the Y should go down by 30. So my Y minimum, I subtracted 30, so I'll put minus 30. And my Y maximum, I wouldn't have to change, but I can. So 70 minus 30 is 40, because those all shift down. So then I look at my graph, and my graph is that same red shape that I saw before, but it has been shifted down, so now it crosses the x-axis. And that point where it crosses the x-axis, that is our 0. So in order to find that, I use second and the trace button, and I pick option 2, find a 0. So enter. Now I do have to interact with the questions here. The first thing it asks me is a left boundary. So I'm going to use my arrow until my cursor is clearly to the left. It also looks like it's above the 0, but it's clearly to the left. That's key. When I'm there, I hit enter. And then I use my right arrow and move my cursor so that it is clearly to the right. Hit enter. Now, what my calculator is going to do is it's only going to look in this little section of the graph between these 2 dotted lines. If you have an older version of the calculator, it just shows you the 2 arrows at the top. It doesn't put the lines down, but it's still just going to look in that wee little section. And so it asks me to guess, so I'm going to be kind and guess, but you truly don't have to. So I'm guessing it's right about there. That looks like where it crosses the x-axis. And so I hit enter, and I get 0.696, exact same answer that I got by the other method. So let's put this all together here on the 0 method. So my graph looks different. And so this is my axis here sort of in the middle, which is the volumes. And the y-axis is still the pressure. And this time we went up to 40 and down to -30. And then my graph started very close to the 40, came swooping down. And I found a 0 right here where it crosses the x-axis, and that was the point 0.696, 0. And so what is the answer? Well, the answer here is that x value, that's the volume. So where the volume is 0.696 liters. So you can see either method, exact same answer. For me personally, I prefer the crossing graphs over the 0 method, but they work the same in that they give you the same answer, just slightly different on the calculator. So then we're going to move on to new question. So for my new question, I'm going to switch pen colors again. This time we'll go purple. In my new question, it says, for what volumes would the pressure be greater than 19? So pressure was the P in the formula, and I'm going to put in 19, which will show me when it's exactly 19. Okay. In my calculator, I'm going to get rid of this -30 that I have in there because that was not part of the original formula. That was something I used. So going to my calculator, go to my y equals. I'm going to make my first equation 19 because that's the number they asked me about. In my second equation, going out here to the end of it and getting rid of this -30. All right, wipe that out. Now, I want to look in my table again because I want to see that my graph is going to be big enough. All right, so second, we were going up by 0.1s. That seems maybe a little small here. So I'm going to change that back to start at 0, go up by 1. And we'll go second and look at our table. So second graph. So we're looking for when will this be 19? And I see that it'll be 19 somewhere between 1 and 2. So it looks like if my x-axis stays at 5, I'll still be good. And we really can use that first window that we had. So I'm going back to my first window, which was 0 to 5. That part we hadn't changed. And this part we had 0 to 70. And that takes us back to that very first window. So hit graph. All right, so we see the red curve, hasn't changed. We see the blue line, that's at 19. Let's figure out where they meet. So second trace intersection. Enter through the questions. And they meet at 1.174 if I round off. So back to my PowerPoint, let's take a look at this. So this is in the purple. This is volume. This is pressure. This goes up to 70. This goes out to 5. We have our same concave up curve coming down. We have a line across at 19. And we found point of intersection here is 1.174, rounding off. So the question is for what volumes? So I'm caring about the volumes. The first one, the X value. Would the pressure be greater than 19? So I want to look at where is the graph, and the graph is the curve, not the straight line. Where is the curve bigger than 19? And so it's bigger than 19 here at the beginning. All this space is bigger than 19. It's above the line. So I'm going to give my answer as a range from 0 to 1.174 liters. So that's that section. Now, if we want to do letters, we can. It can't equal 0 because we saw that gave us an error message that there's a domain restriction in there that we're not even talking about, but we can't equal 0. That was an error. And then the variable we're looking at is V for volume. And this says greater than, it does not say equal to, so I'm going to just not put an equal to with that. So those volumes could go up to 1.174. Now, you might be thinking, why is this inequality having less than symbols in it when the problem said greater than? And that's because our volumes have to be between a lower boundary of 0 and an upper boundary of 1.174. And when we put in volumes that are in that section, our answer, our pressure, is what's going to be greater than 19.